Yes, dear students, today we discuss about the asymptotic notation. So first of all, you have to know what is called as asymptotic notation. Asymptotic notation is a mathematical notation used to describe a running time of one algorithm and compare the efficiency of a various algorithm. So asymptotic notation means we have to discuss on running time of an algorithm. So running time of an algorithm means whether we take as a order of 1, order of n, order of n square, order of root n, order of log n, order of log n square, likewise. So you have to describe the mathematical notation. So for example, in bubble chart, when the input array is always sorted, the time taken by an algorithm is linear. That is this case. When the input array is in rows condition, the algorithm takes the maximum time, quadratic, to sort the element. That is the worst case. When input array is either sorted or reverse, then it's take average time. This duration are denoted using asymptotic notation. When the input array is neither sorted nor reverse order, then it's take average time. These durations are denoted using asymptotic notation. Here, there are five main types of asymptotic notation. One is big O notation, big omega notation, theta notation, little o notation, and little omega notation. Big O notation. Big O notation is used for upper bound values. Big omega notation is used for lower bound values. Theta notation is used for average bound values. Little o notation resembling loosely bound worst case efficiency, and little omega notation resembling loosely bound best case efficiency. So let us discuss by each and every one what is called as big O, everything. Look at this big O notation. So first of all, your write as always you should write as a big O. So big O notation represents the upper bound of the running time of an algorithm. Thus, it gives the worst case complexity of an algorithm. It is a measure of the longest amount of time. Consider a graph. If consider the graph, f of n, one graph line is there, that is a given function. The algorithm takes running a time just g of n. So compared to f of n, g of n is it take more running time. So this is called as the worst case complexity of an algorithm. In mathematical notation, it can be written as f of n less than or equal to cfg of n. So because notation, it represents the worst case. That means it's a upper bound of the running time of an algorithm. It denotes the upper bound. That means you have taken longest amount of time to execute a program. So next, we have to go to the omega notation. Omega notation represents the lower bound of the running time of an algorithm. Thus, it provides the best case complexity of an algorithm. Very lowest time to execution. Consider an example of the linear search. If the element is present in the first position, means it's the best case. So running time, order of 1, constant time. Consider a graph that f of n is a given function. F of n is given function. Like next one line curve line is there, plot line is there. G of n, see the G of n. That is the lower bound of the running time of an algorithm. F of n greater or equal to G of n. It take a less time. Here it will be represent. Go to the next one, theta notation. Theta notation are asymptotic type bound. Look at the definition. Theta notation includes the function from above and below, that is upper bound and lower bound. Since it represents the upper and the lower bound of the running time of an algorithm. It is used for analyzing the average case complexity of an algorithm. Consider the graph f of n is a given function. The running time may be taken as c1 g of n or above c2 g of n. So in mathematical representation, c1 of g of n less than or equal to f of n is also equal to c2 of g of n. So f of n is a given function, c2gn is the upper bound, and c1 g of n is the lower bound. It is an theta notation. Theta notation, or otherwise it's called as asymptotic tight bound. Tight bound. Upper as well as the lower. Next, little o notation. It is a very simple one, as well as little omega notation. Little o notation is used to describe an upper bound that can be tight. In other words, loose upper bound of f of n. Next, little omega notation. Little omega notation is used to describe a loose lower bound of f of n. Loose lower bound of f of n. So these are comes under the asymptotic notation. This asymptotic notation is any time of an algorithm is represented mathematical expression. So it's very important here how they are described in using the notations.